to whoever gave me the adapter, thank you. You've saved my life, really. And also, I think, is there such a way to transmit the virus over a micro HDMI? Because that's when the Windows crashed, so yeah. Anyway, so welcome. So this is an IPsec and XAuth mod config deep dive. So I'm hoping that this presentation can be your guide to IPsec and VPNs. So for those of you who know me, I like to do really in-depth technical presentations, and I speak really fast, and I have a Slovakian accent. So if you don't understand me, I apologize in advance, but you can always review the presentation and the slides later. And Norm has also notified me that I apparently have 1.5 presentations of time, which means we can go even more in-depth into IPsec. So don't let yourself get scared. All right, let's start. All right, so a little bit about me. My name is Tomas. I'm a system architect, but I really love automation and monitoring. I'm also a MikroTik trainer, consultant, and I work for Unimus. A little bit about us. We are a software platform. We do configuration backup, change management, diffs, automation. Like if you need to push a configuration to 300 devices in your network, a couple of clicks. If you need to search for something for a particular configuration across your entire network, couple of clicks, etc. Check us out if you feel like it. Anyway, enough self-promotion. Let's talk about IPsec, why we are here. So why are we even talking about IPsec, and why specifically IPsec XAuth mod config? So you guys probably know what IPsec is, at least I hope. If not, don't worry, we'll go over the absolute basics. So I've been deploying IPsec in my networks for years and years and years. And we've been doing all types of IPsec, but mostly up until a couple or a year or more ago, we've been doing mostly L2TP IPsec for remote clients, for road warriors. And since we've actually migrated all of our IPsec setups for road warriors into IPsec XAuth mod config, because it's so nice. It's also a new feature in MikroTik. So this has been in MikroTik maybe for, I would say, 1.5 years that MikroTik seriously worked on IPsec and implemented XAuth mod config and improved many of it. And it's actually a wonderful technology specifically for road warriors that I feel like not many people know about and not many people use it. So I figured I'll help you out and show you what it is, how it works, and how it can be implemented, and why I love it so much, and why we migrated all of our road warriors to XAuth mod config. All right, a note for posterity. A lot of my presentations circle around the internet as PDFs. So this is not for you, since you are all here and you can actually see the presentation and hear me talk. But for people that find this later, please also watch the actual presentation, not just the slides, because there will be so much more information that I'll try to convey to you than just in the slides. Anyway, so yeah, our agenda today. We'll talk about IPsec. It's a deep dive presentation after all. So we will go into IPsec, how does it work, what it is, all the juicy details. We'll show a little example configuration of proper IPsec deployments. Then we will go into XAuth mod config. After all, the presentation is about road warriors and about XAuth mod config. So we'll talk about how it differs from your other IPsec options. And we'll show a proper configuration of a MikroTik access concentrator for road warriors and client configurations. And then we'll talk about some other security and other miscellaneous bits. All right, so yeah, before we start, as I said, this presentation will deal mostly specifically with road warriors, remote roaming clients. So site-to-site tunneling should not really use XAuth mod config. You have other options which we will talk about for site-to-site tunneling, but this presentation will focus mostly on road warriors. So of course, since we will talk about IPsec and how IPsec works and go into detail on IPsec, what you learn in this presentation will help you for any and all IPsec related things you will actually do in your network. At least I hope it will. Okay, so part one. How does IPsec work? By the way, this screenshot, it's not just a bunch of random things. This is a technically correct visual explanation of how AES encryption works. Yeah, it's not just a bunch of random things. There will be a link at the end of the presentation, if any of you is interested, to a very good article that explains, it's called a stick figure guide to AES encryption. So this is one of the screenshots from that. You will get a link at the end. Anyway, so what is IPsec? IPsec is a standard for securing communication over public networks, which means specifically IPsec allows us to ensure payload integrity and or encrypt the payload. So if you have some very sensitive data that you don't want others to because we know the internet is an open medium, we know as ISPs how easy it is for you to see your customers' traffic. You should not, but you know how easy it is, right? So if you use IPsec encryption, and the traffic will be unreadable unless you have proper decryption keys. So IPsec functions. IPsec can accomplish two things. Number one is integrity validation of the payload, of the connection which is under the IPsec. This is handled by IPsec Authentication header. So in this particular flavor of IPsec, there is actually no encryption. All that does is ensure payload integrity. So ensures that none of the data carried by the IPsec session have been changed in transit. As you can imagine, this is much less computationally difficult for the router or for the IPsec peer because it only validates the data payload, it doesn't encrypt it. On the other hand, we can also do full payload encryption, which encryption can also validate, of course. So this is handled by IPsec ESP, encapsulating security payload. In this case, we fully encrypt the entire data payload using an encryption algorithm. And we can, but technically we don't have to, also validate if the data has been changed. If you are using ESP, I highly recommend to also do validation. You don't have to, but you should, you really should. If you are doing encryption, you also want to validate if the encrypted data has not been changed in transit. So that's the two main IPsec functions modes that we can choose from. So for the remainder of this presentation, I will actually focus only on encrypting the data. So anytime I say that IPsec encryption, etc., just be aware that it could also just be payload validation should we choose to use instead of ESP. I hope that makes sense. All right, so IPsec session. So to provide these functions, as I said, we'll just refer to encryption from now on, including validation. So to provide encryption of the underlying session that is to be secured by IPsec, we need to first establish an IPsec session. And to establish an IPsec session, there are two phases to this process. Phase 1, which is called the IKE, Internet Key Exchange, and Phase 2, which is the actual IPsec phase. So when you are dealing with an IPsec session, and debugging why IPsec doesn't work, you always have to remember that, first of all, Phase 2 needs to be established, and there is many things which can go wrong during Phase 1 establishment. And then there is Phase 2, which also many things can go wrong during Phase 2 establishment. But you need to remember that, like different layers in your OSI model, IPsec also has two phases that work separately and are responsible for different things. So let's talk about this more in detail. So Phase 1, the IKE phase, is actually responsible for the initial IPsec session establishment. So two IPsec peers that want to encrypt or pass IPsec encrypted traffic between themselves first need to establish the IKE session, which is, after this is successfully negotiated, the two peers can only then start exchanging encrypted traffic. So to establish an IKE session, a shared secret is required. So there has to be one common shared secret between the two peers for them to establish the session. This shared secret can be a pre-shared key, so just a password. It can be a certificate, it can be a key, it can be whatever, but it has to be common across the two peers. Remember that the traffic, however, is not encrypted by this shared key. No, not at all. This shared key only serves to kickstart the generation of dynamic encryption keys, which we will talk about in a second. So how IPsec actually works is that each peer has their own encryption keys. Then there is one shared common encryption key. and how through the magic of data encryption and through the magic of cryptography, without each other of the peers knowing each other's encryption key, they can actually decrypt each other's traffic through the IPsec and encryption process. We won't go into detail into mathematics, but if you really want to know how this works, and if you really want to know the details of the Diffie-Hellman protocol or the Diffie-Hellman algorithms which are responsible for this process of being able to decrypt traffic of the other person without knowing the other person's encryption key, again, there is a link for a very good video series at the end of the presentation which you can watch, which will explain Diffie-Hellman and how this is actually possible. So, back to what we were talking about. So, IKEY session gets established, for which we need a common shared secret. And after an IKEY session is established, IPsec policies are responsible for telling the IPsec service, the IPsec daemon running within the router, which traffic should be encrypted and how. Again, remember that we may choose to do encryption or just validation or the combination of ASP or AH. So IPsec policies are really like the routing table for IPsec. No, they are not the routing table. It's just a comparison so we can imagine it. They are rules, they are policies which tell the router which traffic should be encrypted and to which IPsec peer that particular data stream should be sent. So these policies really decide what to do with traffic, how to encrypt it, and where to send it. So how is traffic actually encrypted? SAs, security associations, are responsible for actually encrypting the traffic. So how does this work? IKEY session is negotiated, SAs are built, and then according to IPsec policies, traffic is encrypted and sent to proper peers. IPsec, it's not that hard, right? All right, so let's go more in depth. Let's visualize this. And I'm sorry, you probably can't read these little descriptions, so I will read them for you. So let's visualize the IPsec process. First, we have phase one. During phase one, we establish an IPsec session to our IPsec peer. So of course, we validate all phase one settings. Does the shared key match? Do we have common supported encryption algorithms? Do we have common supported hashing algorithms, etc.? And then if everything is okay, we establish an IKEY session to the peer. So now phase one is complete. We established an IKEY session with our IPsec peer, and we can move to phase two. In phase two, we build SAs, security associations, according to our policies. So our policies tell us which traffic should be encrypted and where we should go, and for that traffic, we build security associations. Again, to build those SAs, we need to have common encryption algorithms and hashing algorithms on both sides of the IPsec tunnel. So to build SAs, we first need to validate if all the settings between our IPsec peers match. If they do, SAs are built, and proper traffic, as dictated by our policies, is encrypted by these SAs. Note, this is vastly simplified, but it is enough for us to understand how IPsec actually works. Okay, so a bit more specific to MikroTik. So please note that in RouterOS, before any of the IPsec processes start kicking off and take place, there has to be some interesting traffic. Why? Well, this is, of course, for optimization. If there is really no traffic that we need to encrypt and we need to secure with IPsec, it doesn't make sense to build IPsec session, because IPsec session establishment is an expensive process to generate the IKEY keys, to do all the exchanges, etc. So in a MikroTik, in other words, first there needs to be some traffic matching an IPsec policy, and only then all of the IPsec process that we see here is actually kick-started, all the process goes through and traffic gets encrypted. How does this work? It is very common and very normal when you first start to ping a peer on the other side of an IPsec session for the first couple of pings to time out. Why? Because that's the first time that the router sees some interesting traffic that should be encrypted by IPsec, so it starts kicking off the entire process. While this is going on, this takes a couple of seconds, so we will have a few ping timeouts, and then immediately the ping starts kicking off and being inside of the IPsec tunnel. So just be aware that this is completely normal. This is just how IPsec is handled in RouterOS. Okay. So any questions so far? We have time, so I think I will take questions as they come rather than everything at the end. Any questions so far? Everybody okay? All right, great. So let's continue. So let's take a closer look at phase 2. What happens in IPsec phase 2? So as we mentioned, we need the policies. The policies are what is really the phase 2. And the policies dictate, first of all, what traffic should even be processed by IPsec. As you can imagine, just deploying IPsec won't magically secure all of your connections to the internet. No, because we need a peer on the other side, right? So it needs to be a mutual, both sides. IPsec is a mutual relationship. So policies actually dictate what traffic should be processed by IPsec, to which peer this traffic should go, because that's also very important, because each peer can have different encryption settings and other things. What to do with the traffic? Do we just authenticate or do AH, or do we also encrypt, do ESP, right? And of course, how to process the traffic. Should the traffic be processed in tunnel mode or transport mode? Okay, so we have something new here, tunnel mode versus transport mode. So let's talk about this. IPsec in phase 2 has 2 modes. So these modes are tunnel and transport mode. Let's see what they are and what they are for and what's the differences. So transport versus tunnel. In transport mode, IPsec secures a data stream. So it encapsulates a layer 4 datagram inside of the layer 4 IPsec protocol. In tunnel mode though, it tunnels traffic, literally. So it encapsulates an entire layer 3 packet inside of the layer 4 IPsec protocol. I hope that makes sense. If not, I have some pictures. So in transport mode, as we said, only the layer 4 part of the payload is put inside of an IPsec, is encapsulated into an IPsec packet and transmitted. So transport mode is used to secure host-to-host, end-to-end traffic between direct 2 IPsec peers. Whereas in tunnel mode, the whole IP packet is encrypted. So therefore, tunnel mode can be used for VPNs by itself. Why? Because we now have duplicate IP addressing, which is what is necessary in order to build a VPN, a site-to-site VPN. All right, so last part that we need to talk about is an IPsec proposal. Again, this is part of IPsec Phase 2. And IPsec proposal is basically our cryptography configuration, our crypto config, how to encrypt the traffic. So this tells our router how to encrypt, what encryption and hashing algorithms to use on our traffic. So yeah, basically, how secure do we want this VPN to be? That's what the proposal is responsible for. So, to sum it up, for router OS, we have 3 main configuration menus that we want to look at. It's IPsec peer, which defines phase 1 settings for our IPsec peers. This really defines our IPsec peers. Then we have the IPsec policy, which defines what traffic to process and how to process it. And then we have the IPsec proposal, which defines what crypto and hashing algorithms to use on this traffic. All right, I hope that makes sense. So let's look at an example. Let's visualize it. Let's see how this really behaves in the real world. So to understand this, on our example, we have a basic site-to-site VPN. We have 2 sites, site 1 and site 2, that are connected by the internet. And for this example, we just have a single /24 subnet on both sides of our VPN. So, in tunnel mode, this actually, so if you want to try this out, you can either model this in GNS or you can connect this in your little lab, whatever you want. These are actually working proper IPsec configs to how to make this work. So this example is in tunnel mode. So in tunnel mode, there is a little, let's see if I can find my highlight tool, which I think is called, come on Windows. We want the, there we go. Come on. All right, so the important part here is that in tunnel mode, we define our peer. So we can see peer 1, peer 2, both sides of the tunnel. So each router is connecting to the other side. Then we define some, so DH group is the Diffie-Hellman group, so that's how phase 1 is encrypted. DPD interval, dead peer detection, so how often should the router check if the other side of the tunnel is still alive. Then we have, you see here, the encryption algorithm and the hashing algorithm and some shared secret. So in this example, we are actually using a pre-shared key that's common across both sides of the tunnel to kickstart phase 1 iKey session. Okay, so phase 1 iKey session in IPsec peer, done. Then we have phase 2, the policy. And we can see that the policy here is telling us for side 1 to this subnet from source address from our subnet, tunnel this traffic. So make an actual IPsec tunnel and tunnel the traffic. On the other side, we have just the other thing. For the remote subnet from our subnet, tunnel this traffic. So that's phase 2. That's our policies. That's our IPsec routing table. Again, I'm using the air quotation marks here because it's not the routing table. It's an IPsec policy that dictates what traffic should be processed by IPsec. Then, very important thing, you must do a net bypass rule. Why? So, as you can imagine, when we are doing a side-to-side VPN, the traffic goes out the WAN interface, the internet interface. So if we have a masquerade rule or something else on that interface, it would change the contents of the IPsec packet, which would invalidate the encrypted payload, right? So you must remember to do a net bypass rule all the way up at your net rule set. Alternatively, if we were here for Yanis Megis's presentation, you can also do this in a raw firewall filter table. One catch, it's much better for performance, but you lose the ability to handle the IPsec traffic within firewall. So watch out. If you do this in raw table, much better performance, etc., but you cannot process the IPsec packet within firewall anymore. If you do a manual net bypass rule, it's another net entry, and it's worse from a performance standpoint, but you keep the option of handling IPsec encrypted traffic within firewall. So those are your options. So again, this is the entire config to make an IPsec, pure IPsec side-to-side VPN in our particular example setup. Okay, so this is in tunnel mode, as we said. Let's go back to transport mode, because we said we have 2 modes. So let's understand how to make this VPN work in transport mode. So in transport mode, it's similar, but a little bit different. So same as before, we need to define an IPsec peer. I hope that's obvious, since we said that IPsec is always a mutual relationship, so we need a peer. But in transport mode, we said that transport mode is used to encrypt peer-to-peer connections, as in node-to-node connections. It's not a tunneling mechanism, which means we need an underlying tunnel. So for IPsec transport mode, we actually create a GRE tunnel, or a GRE tunnel, GRE tunnel, and this GRE tunnel will be what tunnels our traffic. And then we actually secure the GRE tunnel using IPsec in transport mode. So here you can actually see the difference. In IPsec policy, we no longer specify subnets. We just tell IPsec that from some destination to some other, from source to destination address, encrypt this traffic. Don't tunnel it, just encrypt this one session. And this one session which we are encrypting is a GRE tunnel which does the tunneling. So now, of course, we have a tunnel interface which does the tunneling, which means we need some IP addresses on the GRE interface, and then we need some routes in the routing table. So here you can see the difference, right? In IPsec tunnel mode, the routing of traffic was handled by IPsec policies. IPsec policies were telling us where the traffic inside of the VPN should go. Whereas in using transport mode, we are actually using proper interfaces and the router's routing table itself to do the routing, to do the tunneling. And we are only using IPsec to secure the GRE tunnel between our subnets. So that's the difference between transport mode and tunnel mode. All right then, so what should you do? Okay, one more thing before we go further. So in previous setups, for brevity, so I don't have too much config on the screens, we were using the default proposal. Remember that the proposal is the thing that defines our crypto scheme, that defines our crypto setup. So please note the default proposal should be adjusted for better security. The default is very wide, very compatible with everything, but not the most secure. So this really is the proper setup today you should be using for an IPsec proposal. Please note that here we are using AES 128 CBC, which might or might not be enough for your requirements. So you might want to make this an AES 256. Of course, that has performance ramifications. The more strong encryption you do, the harder the CPU has to work, so the more performance it requires to do this. So what do we configure here? First of all, we configure the authentication or the hashing algorithms to SHA-256, SAH-256, because the default SAH-1 has been broken for quite some time now. Cryptographically broken, not as in hacked. In crypto, there is a whole thing, what is broken and what is not is different from the real world. So cryptographically it's broken, but in the real world, it will still secure your traffic. It's just, that doesn't mean that in 10 years, if somebody captures their traffic now, and it's SAH-1, in 10 years, it will be very easy to break. If you use SAH-256, in 10 years, it will still be hard to break. So cryptography is very different. You also have to think about what if somebody stores their traffic and wants to decrypt it later on. That is a big thing, because as we all know, the computational power of our technology goes up with age. So in 10 years, what was unbreakable today, in 10 years will be easy peasy. There is a old, I feel funny saying old, there is an old movie called Operation Swordfish. Anybody remember it? Yeah, anyway, it was a Hollywood movie, but the point is that they were hacking encryption, and what they were hacking was SAH-1, and back in the day, it was they had to use huge supercomputers and whatever. Today, actually, I don't think it was SH. What the protocol was is, or what the algorithm was is beside the point. What is the point is that today you can break that from a mobile phone. And back in 2003, I think when the movie came out, they needed supercomputers to break the encryption. Today you can break it with the mobile phone. So you have to remember with securing traffic, it's always about your requirements. It's always about your specification. How secure should this be now, and how secure should the traffic be if captured in 10, 15, 20 years? It's a anyway, I feel we just went on a nice tangent, so let's get back to what we were talking about. So we adjust the hashing algorithm, we adjust the encryption algorithm, and then we adjust the Diffie-Hellman group that's responsible for generating our keys. So, as I said, you should adjust the cryptographic schema used to encrypt your traffic in the previous setups. All right. So tunnel versus transport. What should you do in real life? What should you actually use in your production networks? So, if possible, my recommendation is to always use IPsec transport mode with an underlying tunnel. Do not use IPsec tunnel mode. Why? Because with transport mode and an underlying tunnel, you get an interface. With IPsec tunnel mode, it's just policies. So when you get an interface, you suddenly can do magic things like OSPF, torch, much easier firewalling, etc. And as you can imagine, when you have a big meshed site-to-site setup with many different branches, and suddenly you need to do complex routing, it's like static routing versus dynamic routing. Doing manual policies within the IPsec policy is very tedious and at some point just not possible anymore. So when you use IPsec transport mode with an underlying tunnel, you get an interface and you can run OSPF and all the other nice things that we are used to and that we love on it. So that's my recommendation. Run IPsec transport mode with an underlying tunnel like a GRE tunnel or something else. All right. So, yeah. Before we move to part 2, the road warriors. So this was the end of like the IPsec overview and the general IPsec stuff. Any questions? All right. So either everyone understands this or I'm doing something good, I hope. All right, so what about Road Warriors? And I just couldn't pass up a Mad Max reference here, so yeah. What are they? So previous cases dealt with a site-to-site VPN, which is nice and easy. It's a site-to-site tunnel. However, just as often, we need to support road warriors, remote roaming clients. And this means that now we want a client-to-site setup, no longer a site-to-site setup. So a single client is not a network anymore, and a single client is just a single client, often behind net. And we want to allow him secure remote access to our network. That's what the road warrior is. So what are our options here? And these options are, by the way, not IPsec. This is all options there are. So we can use PPTP. I'll just say, please don't. PPTP has long been broken. You can break PPTP encryption because it's not even, whatever. iOS, Apple has removed it from their OS altogether. I think it was about half a year or a year ago. So PPTP just don't. You can also use SSTP, OpenVPN, L2TP IPsec, IPsec XAuth mod config, which is the point of this presentation, or you can use IKV2. All right, so let's talk about these options and let's actually compare what these options are and why I chose or why we chose and why I'm talking to you here about IPsec XAuth mod config. All right, so why XAuth mod config? Well, first of all, it's supported in all major operating systems, including mobile. Anything you take in your hand, it supports IPsec XAuth mod config, which is great. Second of all, it's not TCP based. This is important because protocols like SSTP or OpenVPN in MikroTik, because OpenVPN also has UDP mode, but that's not available in MikroTik. So in MikroTik, SSTP and OpenVPN are TCP, based on TCP sessions. And TCP within TCP is not great. You get all kinds of windowing issues because the internal TCP session and the external TCP session have separate TCP windows, which can readjust differently from each other, which causes speed issues and latency and other things. You can also get tons of fragmentations issues, packet reordering, just things you don't want. So IPsec is not TCP based, therefore it's much better than a TCP based tunnel. Also, XAuth mod config has support for keys, certificates, pre-shared keys, a hybrid solution where you need a certificate and a password as well, etc. So it's very flexible. And it has configuration push, which is a big one. So you can actually push certain configuration to your clients. Tell them what to do, what traffic to send into the IPsec tunnel, what traffic not to send there, what DNS server to use, etc. And one thing which I completely love, there is a great free client software which is called the Shrew VPN client. As I said, it's free, so this is not promotional. I don't work for them. I don't have anything to do with them, but I love the client. And it's a big reason why we chose IPsec XAuth. All right, so I think I'll talk about Shrew later on as well, so let's move on. So what do road warriors really need? We really, really want to push settings to road warriors. Why? Well, first of all, IPsec encrypting and decrypting traffic is computationally expensive. And again, if you were at Yanis's Megis's presentation earlier today, he was showing you performance results for different encryption algorithms on MikroTik routers. Some MikroTik routers have hardware encryption acceleration, some don't. So it just depends on what router you get, how much traffic you can actually process in IPsec. But you don't want your road warrior clients to send all traffic to you. See, if they go to YouTube or Facebook, you don't care. You don't want that to go to your headquarters and then out there and get encrypted, etc. You only want to encrypt data and traffic that is really sensitive. And for a road warrior, you just want to encrypt the traffic that goes to your company servers and company resources which the client wants to access. So in order to be able to do that, you need to push settings to the client and tell the clients what subnets, what destinations, what routes, what prefixes, however you want to call it, should be routed into the IPsec session. So yeah, you really want to push routes, and you also want to push DNS. Why? Well, again, if this is a laptop of an employee that needs to access company resources inside of the company, they really probably want to use the company's DNS servers to be able to resolve internal host names. So that's why you want to push the DNS config to the client. So this is really important, and again, a big differentiator for XAuth mod config, because for example, SSTP or L2TP IPsec cannot do that. It will not push settings to the client, so we only have options of routing all of the traffic to the VPN, which, as we discussed, we don't want to do. Or you have to write some scripts or some other solutions to modify the routing table of the client. As we all know, Windows and Linux all have internal routing tables, so you can modify those, sure. But why not just let the VPN take care of it? So XAuth mod config supports configuration push, which is a great differentiator, again, from all of these other technologies. So there is a new standard coming, which is called IKv2. The problem with IKv2 is that currently it's not yet supported in all operating systems, and it's a little bit too new at this point. So into the future, expect IKv2 to take over everything, but so far, not yet. All right, so, and the last, as I said, the last reason why we chose XAuth mod config, and why I encourage you to take a look at XAuth mod config and evaluate it for your needs, is, as I mentioned, managing VPNs and having Shrew client. So having the ability to export, import VPN profiles is a lifesaver. So this is actually my VPN client. As you can see, I have some 20 or 30 VPN profiles which I connect to. These are remote customer networks which I access through a VPN to manage their network. So imagine you have 5 networking admins in your company, and each one needs to set up 20 VPN profiles. With the default Windows client or the default Linux clients or whatever, okay, with Linux it's a bit different because you can transfer configuration files, but with default Windows, built-in Windows VPN clients, it's a nightmare to manage those VPN connection profiles, change them, etc. With Shrew client, you just export your configuration, put it into Git, or however, SharePoint, whatever you have, and every new admin simply downloads the exported configuration profile, imports it, and can use it. All right. So yeah, having the ability to export and import profiles is great. Again, if you have remote road warriors like employees which are outside your company, you don't need to explain to them how to configure a VPN client. You don't need to send them long screenshots and descriptions of how to do this. They just install a single piece of software, import a profile, and they are done. They can connect to your company VPN. So yeah, as I said, Shrew client, great. Exporting client, great. Pushing config, great. And that's why I love XAuth mod config. All right. So yeah, so for the rest of this presentation, we'll be using the Shrew VPN client. Again, as I mentioned, tons of features available for all major operating systems, free. On mobile, you can use the default built-in XAuth mod config clients. All of the mobile operating, well, at this point we only have really 2 mobile operating systems. So iOS and Android have a built-in XAuth mod config client that works with route pushing, that works with DNS pushing, and everything else just works in it. So how do we configure this? So let's move to the actual configuration. How are we doing on time, by the way? Oh, we are doing great on time. Okay, so. Since we are great on time, any questions before we continue? Everything okay so far? Yeah, we have a question down there. Okay, so the question was that I said we would like to push some traffic through the VPN and some traffic not through the VPN. And the question is, don't we bypass the corporate firewall that way? Yes, of course we would. It's a question of what your requirements are, what the security requirements for your client are, and how much IPsec traffic can you handle, what equipment can you buy. So, of course, this is always up to you. If you want to route all the traffic to the VPN, or only some of the traffic, you have the choice, you have the power to decide. So I urge you to decide the proper policy for the proper environment and for your requirements. Any other questions before we move on? Everybody okay? All right, so let's move on. So let's actually see how to configure this. How do we make this XAuth mod config wondrous, marvelous thing work? So, this is how you configure a XAuth mod config access concentrator on router OS. So this is what we are looking at right here is an IPsec peer configuration. There will also be a CLI configuration snippet at the end of this, so you can just copy-paste, but please don't just copy-paste without understanding what it does. I know I hope we all know that just copying random code from the internet is usually not a good idea, right? rm-f/. Anybody? Okay, at least some people laughed. Thank you very much for that. Okay, so this is how we define our IPsec peer. So what do we do here? How do we configure this? Well, first of all, we tell our MikroTik that any incoming IPsec session should match this IPsec peer configuration. Why do we do this? If we have remote clients, if we have our road warriors, they will be all around the world coming in from random IP addresses, whatever. So we just tell MikroTik that any incoming IPsec connection should be matched by this peer to support any random client out in the world. Then we configure our mode to be pre-shared key XAuth. Okay, so that makes sense, right? Pre-shared key, so we aren't using certificates or anything fancy for this example, just a pre-shared key, and we want to use XAuth. And then exchange mode main, and the important thing here is passive. So this, since this is an IPsec responder, this is the access concentrator, the server. In the IPsec terminology, that's called a responder. The responder should be passive. It should not initiate an IPsec session to anyone because people will be coming to it. So we set it to be passive. And then we set our super secret IPsec pre-shared key. So you will notice that since we selected XAuth, there will be two new fields here, XAuth login and XAuth password. Do not use these. These are to be used when the MikroTik is used as an XAuth client, which we are not. We are an XAuth access concentrator, so these two fields should be left empty and not used. All right, so we go into advanced. In advanced, the important thing here is we do not send initial contact, again, because we are the responder, we are not the initiator, people are coming to us. We support NAT transversal. Of course, our clients can be behind NAT, so we support NAT transversal. And then we push some configuration. This is the mode config part. We push some configuration to our clients. More of this in a second. All right. Then we want to generate a policy. What does this mean? Since our clients will be dynamically and randomly coming and connecting to us, we want RouterOS to automatically, dynamically generate a policy. Remember, the policy is what dictates which traffic should be encrypted. So we want to generate it dynamically since we don't know beforehand where and how our IPsec peers will come. So we just do, MikroTik do that automatically. Then we have the DPD, that peer detection interval and timeout. Again, set it to reasonable values so the router can detect where the other side of the tunnel is dead. And then for encryption, watch out. Remember, this is phase 1. This is phase 1, not phase 2. This is not how the live traffic is encrypted. This is the encryption of the IKey session setup. So we set this to be really, really secure. If somebody can break this, then they can so easily break the rest of your IPsec traffic. Why? Because the IKey session is responsible for generating the assays. So if I can break the assay generation mechanism, I can much easierly, is that a word? Easierly break the assays themselves. So this does not affect the performance. Since this is not how we encrypt the traffic, this is only the encryption of the IKey session, so we can set this to be as secure as possible. Again, no performance ramifications here, so we set it to be AES 256, DH group for Diffie-Hellman 248, and SHA or SAH 512 for authentication. Right, so this is the proper config for phase 1, for peer. Then we actually specify our mode configuration, our config push to our clients. So yeah, we just need to specify a mode configuration. In this particular example, we need an address pool, so I hope everybody understands why. Okay, hello. No, that's not what I wanted to do, thanks. So we need a address pool. This will be the IP address that our clients will get within the VPN. This is the same as with other VPNs, whether it be SSTP, OpenVPN, L2TP, whatever. It's the remote IP address that the client will get from our access concentrator. And then, see this split include, this is which routes we are telling the client to send traffic to us, if that makes sense. So if I put 000/0 here, it means the client would send all the traffic through the VPN. If I just specify some routes here, then the client would only send traffic to those destinations within the IPsec tunnel. So this is the configuration which we are pushing to the clients. I then have the option to push the system DNS to the client. So this would push the DNS which the MikroTik itself is using in IP DNS to the clients to use, or I can specify a static DNS to push to the clients. So this is our mode config. And as you saw on the previous slide, we set it here under mode configuration. So you can have multiple presets, you can choose what to send to clients, etc. All right, so what about IPsec policy? Remember the phase 2, the policy? Well, we said it will be generated automatically. So generate policy port strict. In the peer configuration, we'll take care of this for us. So for each valid phase 1, MikroTik will automatically, dynamically generate a phase 2 configuration and push those proper mode config configuration to the client. All right, I hope that makes sense. So last step to actually define our road warriors, to recruit our army. So we can now generate our XAuth users. And we do this simply by going in the IPsec window into users and generating usernames and passwords. I can also overwrite what IP address this particular user will get if I choose to, or I can just leave it to be random from the pool. Really useful thing here, you can actually do radius authentication with this. So MikroTik supports sending the authentication off to a radius server, so you can integrate this with your company SSO, Windows NPS, free radius, whatever you want, you can authenticate off a central authentication server. All right. So this is the full configuration in CLI. So again, you can just copy all of this, paste it into your MikroTik, and something will happen. I recommend understanding what will happen. So that's why we are sitting here. Okay. Any questions for the IPsec configuration for the access concentrator? Yeah, this presentation will be available later on MikroTik website, on YouTube, and everywhere else, so you can just get it there, so you don't have to rewrite all of this craziness manually. Yes, question? Okay, so the question was, in OpenVPN, when you set the default route, when you tell the client to push all config through the VPN will actually disconnect because you are attempting to send the VPN traffic inside the VPN, which is not possible, infinite loop. So no, this works in XAuth mod config. No problem with pushing all traffic. Any other questions? Yeah? Sorry, you will have to yell. Or come here, yeah, I don't bite, at least not hard. Test. Sorry. I think we can somehow make this work. The technology is not too difficult. 1, 2, maybe not. There we go. Take this. Thanks.
What about user groups? Can we make more user groups, multiple, for road warriors?
I see. So yeah, sure. You can make the multiple mode configs, and then that would define basically a user group, because that's a configuration. Is that what you mean? For different users to push different routes and different settings?
Yeah.
Okay. So yeah, you can create multiple mode configs to specify different settings to push to different clients. The problem is, with current MikroTik implementation, the mode configuration to push to the client is based on the peer. So you really can't do it for multiple dynamic peers. But if you know the remote IP address of your peer, or if you can somehow specify your peer, then you can do it. But you can't really do it per username password in RouterOS. So
Thanks.
you're welcome. Any other questions that we have? Yeah?
What if we have several VLANs on our networks and we want a couple of groups to connect to a VLAN and the other group to connect to another VLAN in the
Okay,
network?
so what I recommend is to push all of the routes inside of the mode config for everybody, and then just use Firewall to block access for proper users based on their IP address. Because, of course, every client within the VPN will have their own IP address. As we mentioned, you can even pair username in the built-in user database specify IP addresses, or if you are using Radius, Radius can push a remote IP address and then just handle the security in the firewall. Anything else? Anybody else? All right, so nobody else? All right, I guess we can continue. All right, so how do I configure the client? So again, these are screenshots from the Shrew VPN client. So if you are using the built-in Windows client, it will be a bit different. If you are using the built-in Android client, it will be a bit different. But I hope that by this point you understand IPsec well enough to be able to figure it out. So for Shrew, here we are defining a new IPsec connection. So hostname, where are we connecting to? What port? 500, UDP 500 is the default iKey port. All right, so configuration, iKey pull config. So here we are telling the client to pull configuration from the mode config that the access concentrator will send. These things should be obvious. We obtain our IP address from IPsec. MTU, I don't recommend going much higher than 1300. You don't want fragmentation within the tunnel. So if you do 1300, you should be safe pretty much everywhere. All right, so then we define our client. So again, we want to support NAT transversal, of course, because if we are behind NAT, we want IPsec still to work. Other options here are not really as important. We support that peer detection and other things. And then in name resolution, again, we have on the client, we have the option to choose if we want to accept what is pushed to us from the access concentrator. So here we say enable DNS and obtain DNS automatically from the mode config that our access concentrator is sending us. All right? Next page. All right, so next. We have authentication. So we see here we are saying mutual pre-shared key plus XAuth. What does this mean? For phase 1, remember we have the pre-shared key for phase 1, and then to authenticate to the VPN itself, we use a username and password, just as we have set up on the access concentrator. And then we have some local identity, remote identity, and credentials. So what do we do here? Local identity will be IP address that's automatically discovered. Remote identity, we don't care. The only thing we really want to configure here is the pre-shared key for phase 1. So this will be the same across all of your clients and the access concentrator. All right, let's continue with the client-side config. All right, so then in the client side, we have settings for phase 1 and phase 2. And so, of course, the settings here need to match exactly to what we have defined in IPsec peer and in our proposal in RouterOS. Why? So phase 1, I hope it's obvious to be able to establish the IPsec relationship. Both sides need to agree on certain rules and certain other things. So yeah, DH, this is the Diffie-Hellman group. Group 14 is equal to MODP 2048. So the config here will match to the config that we had a couple of slides ago. If you choose to configure it differently, you have to make sure it matches. And again, AES 256 for phase 1 with SAH 512 hashing. So that's our phase 1. Then for phase 2, this has to match to the policy. Remember we said that phase 2 and the policies are how the actual traffic is encrypted. So of course, in our case, we are using AES 128 CBC with SAH 256 and MODP 2048. So this has to match. And then finally, we have IPsec policy. and this just tells the client to generate a proper IPsec policy, and then the access concentrator will also dynamically generate the proper policy. So this is the full client configuration. As you can see, it's quite a bit. But hopefully you should understand all of these fields. They are the same across the access concentrators, across router OS, and across the client. They're named a little bit differently, but it's the same IPsec principle. All right. So now that we have our client configured, yay, let's not do this manually anymore. That was so much things to do. You can just export your profile, send the profile off to your clients or to your fellow networking administrators in a company. They can just press one button, import, insert username, password, and you're connected to your company network. So that is really that. I would like to say it's that easy, but it's not. I don't know if that's the proper term for all of this that we just did. So yeah, so some other final security and other miscellaneous bits to talk about. Do we have any questions before we move on? Any questions for the client-side configuration? Anything else we need to clarify? Are we okay? How are we on time? Okay, we are good on time. All right. So, firewall rules. First of all, security. What do I need for clients to be able to connect to IPsec? Well, I actually need 3 firewall rules in the input chain. Obviously, since the clients are connecting to the router itself, the firewall rules need to be input chain. So we need UDP 500, which is IKey. We need UDP 4500, which is the net transversal. Remember we said that we should support clients behind net, so we also need that. And then we need to accept on input IPsec ESP layer 4 protocol. This is not a port, this is layer 4 protocol, not TCP, not UDP, IPsec ESP. Of course, if I were only doing payload validation, only data integrity checking, I would do IPsec AH here, remember? All right, so that's all we really need. Of course, this doesn't deal with the forward firewall that should be filtering the traffic from the clients going through the VPN. This is only to be able to establish the VPN. You still need to handle clients' traffic in forward chain so you can properly segment them off, separate it, etc., etc. All right. So a routing node, if you have a bigger routed network, OSP, BGP, whatever you do, well, there's not that many other choices. I hope you aren't doing RIP. So remember to add proper routes. Again, IPsec policies are just policies. And if we are using XAuth mode config, it's not transport mode. There is no underlying tunnel. It's IPsec tunnel mode, which means that if I redistribute connected or static routes within OSPF and I have a bigger routed network, the rest of the network will not know how to get to the VPN client because I am not redistributing them because they are not in the routing table, they are IPsec policies. So remember to create the route in the routing table. It can be a black hole route, that's fine, doesn't matter, to somehow redistribute the client IP address pool to the rest of the network. So the rest of your network knows that the traffic for this IP pool, which I give out to the IPsec clients, should be routed to the IPsec access concentrators. All right, so where to learn more? Are you still hungry for more details? As I mentioned, 2 great videos on the basics of encryption. This is from PBS Infinite series, which is a great YouTube channel about mathematics and other things. So they explain really well how encryption works, what is symmetric encryption, what is asymmetric encryption, etc. I mentioned that there is also a great video on how Diffie-Hellman works. If you want to know how the encryption magic that one side has a certain key and another side has another key, yet they can still encrypt and then decrypt their own traffic through the magic of encryption, the Diffie-Hellman video will explain that to you. Warning, it involves a lot of math, but it's put in a way that hopefully everybody should understand it. And then there is the stick figure guide to AES, which is about a 40-page, where the original screenshot with the crazy AES was from. All right. So some other things to watch and listen to. I have a YouTube channel with just all my other presentations from all the other moms that I've done in-depth, deep dive presentations. Feel free to check it out if you feel like it. I am also a part of the Brother Wisp. We are a bi-weekly networking podcast. If you like it, give us a listen. We like to ramble on about different networking and ISP-related things. And thank you very much for your attention.